Hello everyone, my name is Nicoya and this is the Boss RSD-10. This is sure something. I don't know what Boss was thinking when they made this, but they were smoking some good stuff. This is a delay slash sampler slash kind of weird effects box, and judging by the fact that one of the knobs was replaced, and I've cleaned this up a lot, but it was looking filthy before. It has been through some shit. So the problem here is that we do not have sound output, although we do have power. So if we go ahead and plug it in and power it on, we have a power light, and the LEDs are responsive to our inputs here, so that's a good sign. But if we hook up a signal, it doesn't go anywhere. So we need to pop this open and have a look inside and see what's going on. Okay, so we have direct access to the circuit board here. There is actually two layers of circuit board. They have the digital board at the top here and the analog board at the bottom. And they are squished together with these standoffs in a really annoying way, which makes pulling this apart really difficult. Luckily, we're not going to have to go in any further than this to do our initial investigation. Because what I would like to do is I would like to follow the signal from the input jack into the circuitry and see where the signal disappears, because even in bypass we are not getting any sound on the output at all, and so there's not many components between the input and the output when we're in bypass, and that all is on the analog board, which we have access to. So that's pretty cool. Now if we do look up in the top corner here, let me zoom in for that. So up at the top corner here we can see that the power input jacks have taken a hit, and they've cracked the circuit board here, and someone at some previous point has made a repair. And if you don't recognize that material there, that is solder wick. So I guess it works. Anyway, this is a good chance to point out that not just the power jacks, but every jack on these half-rack Boss devices is completely unsupported and just is soldered directly into the circuit board. So you do need to be careful with these, like don't go smashing the jacks on the back, or you will have to do a repair. So this may be foreshadowing, may not be, who knows. Anyway, I think I lost my train of thought. So with that little note out of the way, let's go ahead and diagnose this. As I was saying, we can input audio into this section here, into this jack, and it doesn't make it to this jack, and again, there's just the analog stuff in between here, so I'm going to go ahead and turn on my function generator and my oscilloscope, and we are going to just trace through and see where the audio stops. Okay, so we got our signal generator putting out a 500 hertz sine wave here, and that'll be the blue trace on the bottom, and the yellow trace is where I'm probing, and so let's probe the signal coming in first. So we can see that we have the signal coming in with a little bit of noise, but that's to be expected. And then we follow the trace around. We have a resistor here. You can see on the other side of the resistor, the signal is still there. And this is the input level resistor that's switched by this switch over here. So that's fine. Next up, it looks like we go over to this capacitor. And on both sides of that, we see the signal, and it has some DC offsets there. Let me put that back to AC. There we go. So if we do AC coupled, you can see that we have our signal. And then we have our 3 here, which is the next part of that trace there. And that goes, I believe, to the center pin of this transistor. It does. And so, you know what, let's just try probing this one. We see nothing, so that's probably like a power pin or something. And then we see a clipped signal, which is not great. And in fact, if we dial back the voltage here a little bit, so that's 2 volts, that's 5 volts, and we'll put this back DC coupling. Then what we will see here, so on the center pin, we have obviously our smaller amplitude signal now that we're 5 volts per division. But on the output here, we're kind of, you know, bouncing up to almost 9 volts, and we're just seeing the top of our sine wave now. And so that's telling us that something weird is going on here. So if we follow the traces from this transistor, we eventually end up at this op amp here. And if we check the, this is just like a single inline op amp here. So this is the V plus pin here. And it's showing 9 volts as it should be. And 9.32 in fact. And if we go, there should be like, I can't remember which way it is, but we have our 3 op amp pins. And then we should have ground here. And that sure doesn't look like ground, does it? So if we follow this trace here, we can see that we come out into this big port here. And this is pretty obviously ground. And we come back through here, and we come back through here. So we can see that, for example, on our input jack here, that is actually ground. We're not jumping up here. But when we get to this side, like if we look at R4 here, we have a lot of voltage. And so somewhere between here and here, we are losing our conductivity of this trace. And so, you know, this trace, this fill, it goes out here to this jack here, goes through this pin here, and then it goes out this trace. And by the time it's in this trace, we are seeing, what is that? 8 volts. So we need to concentrate our inspection into here. So let me shut off some of this equipment so it's a bit quieter in here, and we'll zoom into this area and we'll see what's wrong. So with just the cursory examination here, we can see that something's going a little weird. You know, on this pin here, we have what looks like sort of a normal solder fillet, but on these 2 pins here are kind of solder blobs. And of course, if you are eagle-eyed, you'll notice that there is actually a crack that goes all the way around here, and it goes right through our ground trace. And so this part of the ground trace is just floating, and this part of the ground trace is actually a ground potential. And so since this is powering our op amp on our input stage, as well as Q1, which is just down here, you know, that is going to be a problem. We don't have power to our op amp, we don't have proper bias to Q1, and our signal is going nowhere. And so I am going to say with pretty good confidence that if we bridge this break in the trace here, that we will have a working unit. So let's break out the soldering iron and scrape away some of this solder mask and see if we can fix this. So the first thing I'd like to do is clean away these giant globs of solder and get a slightly more reasonable amount of solder on there so that it's not sort of hanging over the side of the traces. So got my desoldering gun and let's go to it. All right, that is much more reasonable. Now I need to scrape away the solder mask here. And we'll go ahead and tin this up. So that is nicely tinned. So we have 22 gauge bus wire here. And that is stuck down there. And well, it was stuck down there until I melted it again. I think I need a little bit more solder on here, which means this is probably going to go springing away. All right, so we can do a continuity check here. And we see that we have continuity between these pins for some reason. And there is a reason for that, and that is because these are actually switched input jacks. This one, when it's closed, or when there's no plug plugged in, grounds these two contacts together. And over here on our 1/4 inch input, we have basically a pass through from the RCA input into the actual audio path. And so from here, because we have nothing plugged in, we're still connected to ground. If we plug an RCA jack in, we should see nothing now. And we have an open circuit. Or if we plug in a 1/4 inch jack, we should see an open circuit. So everything's going perfectly fine here. And we do have connectivity down to, let me see, can I get both of those on screen? There we go. So we have continuity from here down to here. So that's good. So we now have continuity through this path here. I'm going to goop this up with some solder mask just to make sure that it doesn't get knocked out of place. I'll put the case back on and we will test it out. All right, let's go ahead and try the basic delay functions first. Well, I'd say that works. And then there is the weird function, the sampler function. So if we go into mode A, this should auto trigger. And we blinked and we are good. So now if we go into this mode and we hook up my foot pedal to the trigger, then that is the foot pedal there. You can barely see it on the screen there. Now, for whatever reason, it triggers when I lift the foot pedal off. But I guess that's just a polarity thing, so whatever. Point is, it works. It does its sampling thing. We can also do a chromatic sample. So if we switch this to the keyboard input, and we'll go to an init patch, and we'll just give ourselves a square wave with no shape. That is very low frequency. Let's try something a little higher. So that is definitely the sampling playing back chromatically. If I put this into the regular output here, you can see here it's just a square wave. So this is the craziness of the RSD being its thing. Tracking's not perfect, but I mean, that's just a matter of the technology. There is like a billion different ways you can screw around with this thing. It is so weird. In fact, I'm actually going to go grab my drum pad and see if I can use the pad input as well, because that's another way you can trigger this. Let me try that. Okay, I now have a kick drum pad attached to the unit. It's supposed to pick up the dynamics. It seems to be a little bit iffy, but it seems to be working, so kind of cool, I guess. And let's not forget the nuttiest mode, where if you hook up two keyboards, you know, as one does, you can play a tone and then change how the effect is actually pitched. Yeah, this is one of the weirdest things that Boss/Roland has ever come up with. This, along with the pitch shift delay, which I think people find a little bit more musically useful. But I am going to have fun with this. Let me tell you, this is crazy. I'm also going to get the correct knob on here. And I hope you enjoyed that video, and I will see you on the next one.